So this is how to balance chemical equations. We have the reactant side over here with SN3, N2, and K4, and the reactant side is going to make the product, which is SN9, K6, and N8. Okay, so let's figure out how many SN atoms we have over here. We have 3 SN atoms over here. Right here we have 2 N atoms. And right here we have 4 K atoms. So now over here we have 9, 6, and 8. Alright, so let's look at the SN atoms first. So we have 3 and we have 9. What you want to do with chemical equations is you're going to want to make that number of atoms on the products and reaction side balanced or equal. The reason we do trying to balance them is because of the law of conservation of mass, which states that in chemical reaction the mass of the product equals the mass of the reactants, which is what we have here. So now we see we have SN3 and SN9. So you have your coefficients, which is in front of each atom right here, and if you put a number there, that number will multiply the atoms behind it. So you see 3 and 9, and so you're going to say, what's a multiple of 3 and 9 that could make a common number or a multiple that relates with 3 and 9? And you see that you have 3 SN atoms and you have 9, and you say, oh, well, that's 9 is just 3 times as many SN atoms I have on the product side as I have on the reactant side. So what we're going to do, we're going to multiply SN by 3 and make it 9. So right now, both of these are balanced. Okay, so we're going to move on to N2. Alright, so there's 2 N atoms and 8 N atoms. So now, what you want to do is so you're going to say, okay, so 2 and 8, what could be a common number or multiple? And then you see that it's 4. So you're going to make this 4, make this 8, and then you have it checked off right here. So now comes the tricky part. You have 6K and 4K, which don't look like they have a multiple or common number, or number in common. So what's going to happen is you're going to have to multiply 4 by 6 and 6 by 4. So now this is going to make it 24. This is going to make it 24. Alright, but now what changes is that these two atoms are connected. So these two atoms are going to change. So you're going to see that we're going to change the coefficient so both the atoms can be equal on each side. So now you have to multiply 4 by N8 because that's the coefficient, and the coefficient multiplies every atom behind it. So then you have 4/8, which is 32. And then over here you have 2. So now to get to 32 N atoms from 2 N atoms, you're going to have to multiply by 16, and you're going to get 32 N atoms. And this is going to check out. Every atom is going to be balanced with each other. Okay, now that we have this problem set up, we have over here, we have 6, and we shouldn't have that over here. Over here we have 6 because that should be the same as 1.5 times 4 equals 6, and that's the same as K6. So now what won't work with this is that you can't multiply an atom by only half of a atom. So now what we're going to do is, if this ever occurs, all of them are equal at the current point right now, right? So what's going to happen if this ever happens, to make it a full atom, you're going to multiply every coefficient in front of the atoms by 2. So this is going to become, instead of 3, it's going to be 6. This is going to be 8. This is going to be 3. This is going to be 2. This is going to be 2, because there is only one of each atom on these 2. Okay? So now, we're gonna erase what we have. Okay, so now we have 6 SN3 atoms, which is gonna be 18. So we're gonna do 18. Right here we're gonna have 16 because we have 2 8s. Right here we're gonna have 12. Right here we're gonna have 18. Right here we're gonna have 12 and 16. And as you can see, the N8 goes with the N2. Both of them are 16. So these two check out. You got 12 Ks, and over here you got 12 Ks. These two check out. And then right here you have 18 SNs and 18 SNs. They both check out. And that's another way how you can balance equations with a decimal. But just remember that a decimal, you can't multiply by a decimal for your final answer. It has to be, every coefficient has to be multiplied by 2.